Hi class, let me give you a quick example of why multiplication of two actual negative numbers has to be a positive value. Now this is not a formal proof, but it is a good example to actually give your students if you ever encounter why this is actually true. Now, before we jump into the example, I'm going to use the following property. And the property says, well, let A be any number. And then the property is basically dealing with the multiplication of 0. So A times 0 is equal to the values of 0, regardless of what technically A happens to be. And then let me carry a multiplication for this example. I want a multiplication that has the result of 0. So in this case, let me multiply a -4 times 0. So we already know that -4 times 0 has to be the values of 0. But then what I'm going to use to illustrate the multiplication, it's technically this portion here. And what I'm going to say is, I'm just going to express the actual left-hand side. So in this case, I'm calling this the left-hand side, and this is the right-hand side. And I'm going to start with the left-hand side. So in this case, the left-hand side of this equation, I'm just going to express it as -4 times 0. It's equivalent to the following. Now, I'm just going to rewrite it as -4 times, and the value of 0, you can actually express it with any two numbers that add to 0. You need a positive and a negative in order for this example to make sense. So let me just use technically the values of 3 plus the values of -3 as well, basically the two numbers that technically add to the value of 0. So what we're doing here is we're basically saying that 0 can actually be expressed as those two. So nothing has actually changed. We're still talking about, well, -4 times 0. And we already know by the property above that this is equal to the value of 0. Since technically 3 plus -3 is equal to 0. So you still have 0 times -4. Now next, I'm going to be using the actual distributive property and multiply those two. So I'm still working on the left hand side, and on the left hand side you're going to have that -4 times the values of 3 plus the values of -4 times the values of -3, and this has to be equal to 0. This is because of our original premise. I'm going to box that in so that it's clear what we're actually working with. Now, what you have here is that the left hand side of the actual equation, and notice I only have numerical values, well, technically has to add, and it has to be equal to 0. So on the left, if you were to use repeated addition, -4 times 3 is -4 plus -4 plus -4. Or technically, let me write it as -4 plus -4 plus -4 plus -4 times 3 should equal 0. Or using repeated addition, this has to be equal to -12. So this is -12 plus, in this case, -4 times 3, -3, has to equal to 0. Now, since the quantities on the left-hand side end up equaling 0, the only way this is possible, it's only if, so this is only if, oops, I lost the file. So this is only true if you technically still have the values of -12 plus the values of 12 is equal to 0. So therefore, the only conclusion that we can actually come up with in this equation is that -4 times the values of -3 has to be equal to a positive, in this case, a positive 12. So therefore, the multiplication of two negatives must be positive. As I stated before, this is not a formal proof, but it'll give you a good idea on how to explain if you ever encounter why the multiplication of two negative numbers is equal to 0. So, not equal to 0, it's equal to a positive. So we're looking at this portion here has to be 12 because they only add a 0. So therefore, multiplying those two must be, in this case, -4 times -3. It has to be the values of 12.